Alright, this video is on graphing polynomial functions in factored form. Our objective today is for you to be able to identify the end behavior and the zeros, which are called the x-intercepts of a polynomial function in factored form. You will be able to sketch a graph of a polynomial function in factored form. When I say sketch a graph, these are going to be rough estimates of what the graph actually does look at. For example, one of the goals is for you to start identifying turning points. And turning points are where the graph changes direction. So if you look at this graph that I have here, this particular graph has 3 turning points. It has a turning point here, a turning point at the top of this, and a turning point here. Because this graph is decreasing from left to right, and then once it hits this turning point down here, it's going to start increasing, and then it hits this turning point here, and now it starts decreasing, and then it's increasing at the end. So when we find these turning points, these are going to be approximate values, because if I'm graphing this by hand, this is going to be extremely hard to do, because my x values could be decimals or fractions, and so this will be very, very hard to come up with the exact actual minimum value here, maximum value here, and minimum value here for my third turning point. And so those will be very, very hard to come up with. Alright, the first graph that we're going to graph is f of x equals x plus 4 and x minus 5. And one thing that I want you to realize about this particular graph is that this graph is a quadratic graph. And the way that I know that this is a quadratic graph is because this graph has two factors. And the two factors are x plus 4 and x minus 5. And so that means that I'll have two zeros. And I'll show you how to find the zeros here in just a little bit. But if you're having a hard time seeing this as a quadratic graph, what you can do is you can simply FOIL this out. And so my first term will be x times x, which is x squared. My outside term will be x times negative 5, so negative 5x. My inside term will be 4 times x, so 4x. And my last term will be 4 times negative 5, so negative 20. And if I combine my outside and inside, I have x squared minus 1x minus 20. So I can see that this is a quadratic equation, meaning that this is an even degree, which is a second degree because this exponent here tells me my degree, and it's a positive leading coefficient. So I know that the graph of this will be a right side up parabola, because second degree equations with a leading coefficient that is positive will be a right side up U-shaped graph called a parabola. So the only thing I really have to know about this graph is if I look at this x times this x, which is my first terms, and see that that is x squared, then this x squared is going to tell me my end behavior. So my far left end behavior is up, and my far right end behavior is up, so I know that this graph is up, up. So my first step of doing this particular problem is going to be to find the zeros. So I'm going to find the zeros here by taking x plus 4 and setting it equal to 0. That will give me x equals negative 4. Then I'm going to take x minus 5 and set it equal to 0, and I end up with x equals 5. And so my two zeros for my particular graph, and those will be the first points that I'm going to plot, are x equals negative 4 and x equals 5. Alright, so on my xy coordinate grid here, I'm going to plot my zeros, and my first zero was, I said, negative 4, so I'm going to put a dot on negative 4, and my second zero was positive 5, so I'm going to put a dot on positive 5. And so then what I'm going to do here is I remember that parabolas are symmetrical figures. So I know that the vertex has to land in between negative 4 and 5 so that the left side and the right side of my graph are perfectly equal. So I'm going to actually do a little trick here where I'm going to count the squares that I have between negative 4 and 5. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 squares between negative 4 and 5. So if I go half of 9 is 4.5, and I would count backwards 4.5, so 1, 2, 3, 4.5 is going to land me right here. So that means that the first, and that x value is a half, so that's going to be my first value that I'm going to plug in to my xy table, because that's where my vertex is going to land, is going to be, my vertex is going to be at a half something, which that something is what I'm going to have to find. Okay, so we're now back at our table, and we're going to plug in a half. So I'm going to put in my parentheses, I'm going to take a half times, or plus 4, sorry, and then I'm going to take a half minus 5, and I'm going to multiply those together. So I'm going to have 4.5 times negative 4.5, and that is negative 20.25. So I'm going to plot that. That will actually be my vertex of my graph. So I'm going to put a V here for vertex. While I'm here, I'm going to go ahead and plug in some more numbers. And so I randomly picked some numbers that were between negative 4 and 5 on my XY axis. So I'm going to plug in 0. So I'm going to have 0 plus 4. And I'm going to have 0 minus 5. So I'm going to have 4 times negative 5. And that'll be negative 20. So that'll be a point. And I'm going to put in negative 2. So negative 2 plus 4. Negative 2 minus 5. So I'm going to have 2 times negative 7. And that'll be negative 14. And the last point I'm going to put in is I'm going to put in 4. So I'm going to have 4 plus 4. And I'm going to have 4 minus 5. So I'm going to have 8 times negative 1. So that'll be negative 8. So these will be the points that I'm going to plot on my graph. Alright, so we have the points negative 4 and we have the point positive 5 plotted for our zeros. And so what we're going to do is I'm going to go ahead and plot my vertex. And remember my vertex was this point right here, 0.5, negative 20.25. So I'm going to approximate where that is. So that's going to be about right in here someplace, about as close as I can get. And then I'm going to go ahead and plot my other points that I had. One of the points I had was negative 214. So negative 214 is going to be about right in here. And I had the point 4, negative 8. So 4, negative 8 is going to be about right in here someplace. And remember that if I want to, I could reflect those points. And so if I reflect 4, negative 8 over from, I'm at 1, 2, 3.5 from my line of symmetry, so go a half, 1, 2, 3, so about right in here would be that point. And this point is 1, 2.5 away from my line of symmetry, so go 1, half, 1, 2.5, that point's going to be about right in here. And so then if I sketch my parabola is going to look something like this. And you notice that my far left behavior is up, my far right behavior is up, and my two zeros are negative 4 and 5, and then this right here is going to be my vertex, and my vertex was 0.5, negative 20.25. So to check this, I went ahead and graphed this on Desmos, and so according to Desmos, this is what my graph should look like. So I am pretty close to what my actual graph looks like. Alright, so for our next example, we're going to do a cubic function. And this particular problem is a cubic function because it has 3 factors. My first factor is x, my second factor is x plus 2, and my third factor is x minus 1. So if I would multiply x times x, I would get x squared, and then x squared times another x, I would get x cubed. So I know that this will be a third degree equation. So the first thing I'm going to do is I'm going to find my zeros again. And so my zeros are x equals 0, x plus 2 equals 0, which is negative 2, and x minus 1 equals 0, which is a positive 1. And because when I looked at those x's and I took x times x and got x squared and x squared times x and got x cubed, I know that because this is a third degree equation, which is an odd degree, and it has a positive leading coefficient, I know that my far left behavior is going to be down and my far right behavior is going to be up. So I can get what I think the general shape of this graph is going to be. So to help me out, what I did was I I have to pick points that are in between 0, -2, and +1. So the first thing I did was I picked a point to the left of -2, which was -3. Then I picked a point between -2 and 0, which was -1. And then I picked a point between 0 and 1, which is my half. And then I picked a point to the right of 1, which is my 2. And I'm going to sub these in for each one of my x values. So my first one I'm going to do is I'm going to have -3 times -3 plus 2 times -3 minus 1. So -3 times -1 times -4. So this will be a +3 times a -4, so this will be a -12. My next point is going to be -1 that I'm going to sub in, so I'm going to have -1 times -1 plus 2 times -1 minus 1. So -1 times 1 times -2. So -1 times 1 is -1, -1 times -2 is +2. The next point I'm going to put in is going to be a half, so I'm going to have a half times a half plus 2 times a half minus 1. So I'm going to have a half times, this is 2.5, which I'm going to change 2.5 to 5 halves. And so this will be a half times 5 halves, and then a half minus 1, this will be times -1/2. So when I multiply fractions, it's top times top. So 1 times 5 times -1 is -5. And then bottom times bottom times bottom, which will give me 8. So this will be -5/8. And then finally I'm going to put in 2. So I'm going to have 2 times 2 plus 2 times 2 minus 1. So I'm going to have 2 times 4 times 1. So I will get 8 for my answer. Alright, the next step is to graph our zeros and to graph our points that we found in our table. So my first 0 was x equals 0, so I'm going to put a point on 0. My next 0 was x equals -2, so on -2 I'm going to put a point, and then on 1. And then the points that I picked that were on my table, -3 was -12, so that's about right here. -1 was at 2, so that's about right here. My 2,8 was a point that I picked, so 2,8 was about right here. And if I sketch the graph of this, remember that my x cubed graph was a graph that looks something like this. And so my far left and far right behavior were down up. So that's kind of what this is showing here. So my far left here is going down, and my far right here is going up. So my graph, general shape of my graph is going to look something like this, is what my sketch should look like. Now, notice that I picked other points here. This point was the point 5, -0.625, which looks like approximately what that is right there. And I picked a few other points. -1 was, or -1.5 was at 1.875, and -0.5 was at 1.125. So my graph looks approximately correct. Alright, again I checked this using Desmos, so this is the graph that Desmos is showing, and it looks pretty close to what my graph is that I gave. And just a few key points here so we can kind of sketch and see what it is. Looks pretty close. Alright, so for the last graph we are going to graph x times x plus 2 quantity squared times x minus 1. And you will see that this is actually a fourth degree equation, and the reason why it's a fourth degree equation is because this means x times x plus 2 times x plus 2 times x minus 1. So this quantity squared means that you write it twice, so that you can easily see that this has 4 factors, so this will be an x to the fourth degree equation. I also notice that this is a positive leading coefficient. So my even degree, positive leading coefficient, my left and right in behavior is going to be up, up. So I know that my graph will be going up to the left and up to the right when I go ahead and graph it. So the first thing that I'm going to do is I'm going to find my zeros. So my zeros are going to be x equals 0, x equals negative 2 twice, and x equals 1. So when I plug numbers in, I'm going to pick numbers to the left of negative 2, so I picked negative 3. I'm going to pick numbers between negative 2 and 0, so I picked negative 1. I'm going to pick numbers between 0 and 1, so I picked a half. And I'm going to pick numbers to the right of 1, so I picked 2. And those are the numbers I'm going to plug in. So my first number that I'm going to plug in is I'm going to plug in negative 3. So I have negative 3 times negative 3 plus 2, quantity squared, times negative 3 minus 1. Alright, so I will have negative 3, negative 1 squared times negative 4. So negative 3 times 1 times negative 4, and I will end up with a positive 12. My next number I'm going to put in is negative 1, so negative 1 times negative 1 plus 2, quantity squared, times negative 1 minus 1. So this will be negative 1 times 1 squared is 1, and negative 2. So negative 1 times negative 2 is positive 2. Then I'm going to put in a half, so a half times 1 half plus 2, quantity squared, times 1 half minus 1. So this is a half times 2 plus a half is 2 and a half, which is 5 halves, so 5 halves squared, and then 1 half minus 1 is negative a half. So 5 halves squared is 25 fourths, so this becomes a half times 25 fourths times negative a half. So this will be a half times 25 times negative 1 is negative 25, and then 2 times 4 is 8 times 2 is 16. And so that's what I'm going to graph here in just a little bit. So then I'm going to plug in 2, so I have 2 times 2 plus 2, quantity squared, and 2 minus 1. So this will be 2 times 4 squared, then 2 minus 1 is 1. So this will be 2 times 16 times 1, so that'll give me 32. And those will be my points that I'm going to plug in on my graph. Alright, so again I'm going to plot my zeros. So my zeros were 0, negative 2, and positive 1. Now remember that my end behavior is up to the left and up to the right. And so when I'm plotting the rest of these points here, negative 3, 12 was a point, so negative 3, 12 is right here. Then I plotted negative 1, 2 as a point right here. I plotted 0.5, and I got negative 25 over 16, which is a decimal is negative 1.5625. So 0.5 negative 1.5625 is going to be about right here someplace. And then 232 is going to be way up here someplace. I didn't actually finish plotting it, but it'll be way up there someplace. So remember that since my far left and far right behavior is up, up, when I trace this, what's going to happen is when I come down here, I'm going to come up here, and I'm not going to cross right here. And if I picked more points between negative 2 and negative 1, which I did right here, negative a half is 1.6875. So I know that that's going to be about right here someplace. So it's actually not going to cross the x-axis here. So I'm going to approximate negative a half, 1.6875 is going to be, or positive 1.6875 is going to be about right here. And so I know that there's going to be a bounce, what we call a bounce right here. Then the graph is going to come down and it has to cross through here at 0. And then it's going to have to come back up here and cross through 1 again. And then it's going to go way up here to 232. So this is what this double root here counts as. So when you see x plus 2 quantity squared, and you have x equals negative 2 and x equals negative 2 for your zeros, that means something special. When you have a multiplicity of 2, that means that there's a bounce. And this is what I mean by a bounce here. The graph touches the x-axis and bounces back off of it. It doesn't cross through. So here, where it was x equals 0, This right here is a pass-through, and x equals 1 is a pass-through, that's not a bounce. But when the graph comes down like this, and it touches right here at -2, and then it bounces back off, and it comes back up at the same time without passing through, then that means that that's a double root. So this particular graph here, my zeros were x equals 0, x equals -2, and we say that that has a multiplicity of 2. And then x equals 1 was my other 0. And so this is my fourth degree equation. Okay, again, I typed this into Desmos to see how close I was. And so I'm showing that here on Desmos, I am still showing that there's my bounce right there at -2. So that's a double root. And here's my other 0, x equals 0. And my last 0 was x equals 1. And it was showing far left up, far right up. And so my graph is pretty darn close.